Hello, dear learners. I hope you're fine. Welcome to today's lecture. Today we will talk about simplex method, which is used for optimization problem, and it has certain characteristics. Simplex method is a linear programming method used to obtain the highest possible value of a function. We all know about linear programming method. Simplex method is one kind of that, and it is widely used for function maximization. We can use it in a business for profit maximization or cost minimization. It is very simple to calculate, but firstly, it is complex to understand. So I need your direction to understand that logic or that method so that you can apply it on your next future. Okay, so what simplex method do? Let's consider this graph. There are some curve, three curves actually, one, two, three, and these curves intersects in some points. Uh, if we and this is the area which are occupied by this curve. So if we look closely, then the maximum point or maximum value of the curve would be among any of these points. What simplex method do is actually it find that point for us so that we can solve the problem. Okay, so there are some steps to follow to solve the simplex method. Firstly, we need to set up the objective function and inequality constraints. Then we need to convert these inequalities into equations. Thirdly, constructing the initial simplex tableau. After that, we need to identify the most negative entry. Then we need to calculate and again calculate and this is how we get the final solution. So there are 7 steps. We will solve a problem by dividing it into these 7 steps, and this will help you to understand and to absorb the method easily. Okay, this is our problem. Here is our maximized function p 8x plus 3y for z. We need to maximize this function, whereas these are the constraints. Okay, okay. So simplex method not only used for maximization but also for minimization. Here we will talk about the maximization problem. In future, we will also talk about the minimization problem. This is our first part. Okay, so setting up the objective function and the inequality constraints, and we will now convert the inequalities into equations. So this was our equation, right? So we need to convert it into equations. Okay, these are our inequalities and we need to convert it into equation. Firstly, we need to introduce slack variable. So slack variable, what is slack variable? It is a variable which used to make which used to convert inequalities into equations. So this is already an equation and there is no need to add slack variables, but there we need slack variables, and there will be 3 slack variables. There will be one, there will be one, and there will be another. Those three are different than each others because each inequalities are different. So there we do not have any slack variables, but as the other three equations there will be 3 slack variables. That is why we denoted them as S1, S2, S3, and we multiplying them with 0. As you know, multiplying with 0 means 0. Then the first equation becomes 2x plus 4y plus 3z S1. for first slack variable for first equation, other two are 0, 2x minus y plus 5z, second one is 1 and other two is 0, and 4x plus 9y plus 11z. The third one remains h3 and other twos become 0. Listen, we did this multiplication and we adopted this s1, s2, s3 in all the equation so that we can easily convert this into a table. Okay, and here will be our table and constructing the initial simple table. This is our initial simple table, and if we go back to our last slide, then see, this is our table and these are our equations. Okay, the table structure will be like that. Don't look there right now. I will teach you those things later. Firstly, we need to write the objective function coefficient right there. Here, in basic variable row, all the variables will be there: x, y, z, s1, s2, s3 of the main function. Then here in the column, only slack variable will be available: s1, s2, s3. Okay, and above there, the coefficient of x in the main function, which was 8, will be written y3, z4, s1 0, s2 0, and s3 0. I think you understand that. All the coefficient of the main function will be written there. Here, in below CB, all the coefficient of S1, S2, S3 in the maximization function are written. Okay. Now, here, the first equation, we have 2x. So 2 is written here. 4y, 4 is written here. 3z, 3 is written here. 1 here, 0 here, 0 here. Okay. And last one, 14. So, this is the way to construct the initial table. Okay, we need to write all the basic variable, then we need to create a matrix by using the coefficient of them in their functions. Then the calculation. Okay, so here uh, below we need to find our pj minus cj. So how will we calculate our pj? The calculation is simple. We need to multiply this 2 into 0 plus 2 into 0 plus 4 into 0 minus 8, which is 8. Four into 0 plus minus 1 into 0 plus 9 into 0 minus 3 minus 3. So that is how we calculate our pj minus cj. We multiplied cv with the row, then we subtract with the upper row. And the last one, here is p equal to 0, where we multiply this with this with this, and we add this one. Okay. We multiply 14 with 0, 50 with 0, 81 with 0, and we sum up those things to make our pj value here, which is 0. Okay. Firstly, we need to identify which column we have the highest negative value, which is -8, column 1. So, column 1, so we need to divide our constant b with the column 1. Okay. So, we will divide 14 by 2, which is 7, 50 by 2, which is 25, and 81 by 4, which is 20.25. And this is the way we do our first calculation. Then we will go to our second calculation. So in order to get our maximum function, we need to consider our pj minus cj. That is why we develop this structure. So the first law to get pj minus cj is that the pj minus cj will be greater or equal to 0. Here we have pj minus cj, which are negative values, and some of them are less than 0. So this is not our optimum function. So we need to find our optimum function. Hence, we need to do this calculation again. So here, this row -8, this column -8, it has the highest negative value. So it is our key column. We need to identify our key column, and we need to identify our key row to do the second part of our calculation. Okay. So listen, this column, it has the highest negative value below there, -8. So it is our key column. And this column, it has the lowest minimum ratio, 7. So it is our key row. So our key column is this one, and our key row is this one. Okay. So now we separate our key column, and our key row. So now let us move on to our next slide, where we will calculate and again calculate to find out our optimum value. Okay. Now this was our last chart or last tableau, and this is a new rule to find out our new value. Here, this one is our key row, and this one is our key column, and this is our key element. So firstly, to determine the new value in our key row, we need to just divide those value by our key element. Okay, so 2 divided by 2, 1, 4 divided by 2, 2, 3 divided by 2, 1.5. Okay, now others, for others, we have our next solution. So here we need to understand about entering variable and leaving variable. As S1, it has the value of 0, and it is on the key row, and X, it has the lowest value or highest negative value, and it is on the column of key column. So S1, which has the lowest value and the lowest ratio, will be our leaving variable, and in this position X will enter. So X is written there with its coefficient 8. Okay, and S1 and 0 leaves. So now let's move on to determine our others values. Let us consider how we determine these values. We use this formula to determine these values. Okay, let's check. Suppose, what will be the new value of this 5? We had our old value 5 minus, we have our old value 5 minus corresponding column, key column, which is 2, corresponding key row, which is 3, divided by key element, which is 2, equal to 2. So 5 becomes 2. Okay, we can check another. So how? So let us check the value of 50. So 50 minus 14 multiply 2, key row and key column value corresponding, divided by key element 2 to 36. Okay, so you can check all the stuff by doing calculation. I think you understand the calculation, and the same method we determine our PJ and CJ. Our PJ and CJ, sorry for the typing mistake, and we multiplied this one, 0 with 8 with 1, 0 with 0, 0 with 0, sum this one and subtract it, minus 8 equal to 0. Again 8 into 2, 8 multiply 2 minus 500 plus 100 minus 3, which is 30. Okay, and the value of z, which is 7 multiply 8 plus 36 multiply 0 plus 53 multiply 0, which is 7. So here we have our value where PJ and CJ, uh, uh, where PJ minus CJ have do not have any kind of negative value. We have 0 or greater than 0, 0, 13, 8, 4, 0, 0. So it meets our criteria. So it will be our optimal solution. So let us go to our final solution. So this is our final solution, and here we will write like this: since all Pj minus Cj is greater than 0, which meets the optimality condition. So here x equal to 7, y equal to 0, z equal to 0. Why I'm giving y and z 0 value? Because here in basic variable column we do not have other x and y. So this will be 0. The value of y will be 0 and value of z will be 0. Only the basic variable we have available right there is x. So x belonging constant b is 7. So here we will find the optimal solution if x is equal to 7 and y and z is 0. I hope you understand the simplex method. I tried all my best to simplify this method so that you can absorb this for your understanding. Thank you.